Imagine you are camping in the Santa Cruz Mountains, huddled around a fire with your friends trying to stay warm. You know that if you move away from the fire, you'll get colder because the temperature drops. Now, instead, imagine you are standing next to the surface of the sun. Here's where things get a little strange, because if you move away from the sun's surface, the temperature actually rises. The sun's outer atmosphere, also known as the corona, has an average temperature of 2 million degrees, which is 400 times hotter than the surface. 70 years after this paradox was discovered, we still don't know what makes the corona so hot. The most popular explanation for the coronal heating problem is the theory of nanoflares. These are tiny explosions powered by the sun's magnetic field that might release enough energy to keep the corona at its oddly high temperature. Scientists believe that there are countless nanoflares happening all over the sun, but they are too small to detect individually. So how do we find these tiny solar flares? Well, we know that larger flares produce X-rays, just like the machine in your doctor's office. We might be able to detect X-rays from groups of nanoflares using a very sensitive instrument that wasn't even designed to look at the sun. The NuSTAR satellite was built to see black holes from the farthest reaches of the universe, so it has no trouble seeing solar X-rays. In fact, NuSTAR scientists were worried that direct sunlight might destroy the satellite. Luckily, that didn't happen, and we are using NuSTAR solar data to figure out whether or not nanoflares exist. Now, our quest to understand nanoflares is also a quest to understand the fundamental physics of the sun. The magnetic fields that power these tiny flares are also responsible for giant flares that can eject millions of tons of hot gas into space. These so-called solar storms are what cause the aurora borealis, or northern lights. Harmless storms happen all the time, but the largest ones can shut down GPS systems, destroy satellites, and even blow up electrical transformers. In 2012, an enormous solar storm barely missed the Earth. When scientists calculated how much damage it would have caused, the number they got was $1 trillion in the US alone. Different parts of the globe would have lost power for weeks, months, or even years. Now, we can't prevent these solar storms from happening, but we can work to predict when and where they are going to strike. With enough advance warning, we can turn off vulnerable power equipment and prevent damage. Solving the mysteries of the sun can help keep us safe from its occasional wrath. Thanks.